Hello everyone. In this video, we'll discuss the question minimum moves to equal array element second. So, what the question says, we are given an integer array of size n, and we have to return the minimum number of moves required to make all the elements equal. So, what we have to do, we have to make all the elements of the array equal, and we have to calculate the minimum number of moves required to make all the elements of the array equal. Okay, so what are the operation we can do? You can increment or decrement an element by one. Okay, so we can only perform the operation of incrementing or decrementing an integer or a value of an array by one. So we have to return the minimum number of moves required to make all the array elements as equal, and we can either increment or decrement an element by one. Okay, so the test cases are designed so that the answer will fit in 32-bit integer. Okay, so let us analyze what the question is saying. So this is the basic intuition of the question. We just have to make all the array element as equal. So let's suppose the following cases can be possible. Let's suppose all the elements of this test case array. Let's suppose we are given an array of integer. We have 1, 10, 2, 9. Okay, if all the array elements become equals to 1, this will be the case. Now the corresponding changes require are to change 10 to 1. We require to decrement 10 by 9 to make it 1. For 2 we have to decrement it by 1. For 9 we have to decrement it by 8. So the total changes required are 18. Okay, now here let's suppose all the array elements become 10. Then the changes required are, for 1 to become 10 we require 9 changes. For 10 to become 10 we does not require any changes. For 2 to become 10 we require 8 changes. For 9 to become 10 we require 1 changes. So the total number of changes in this case is 18. Okay, now let us take the third case in which all the elements are equal to 2. So to make 1 as 2 we require 1 change. To make 10 as 2 we require 8 changes. To make 2 as 2 we does not require any changes. To make 9 as 2 we require 7 changes. The total changes we require are 16. So for this case we require 16 changes. Now for the last case we can have all the elements of the array as 9. So in this case the change corresponding to the particular element are, for 1, if we make it to 9 we require 8 changes. For 10 to make it to 9 we require 1 changes. For 2 to make it to 9 we require 7 changes. For 9 to make it to 9 we require 0 changes. So the total changes in this case is 16. So from these 4 cases we can say the minimum changes required are 16. Okay, so for this test case our answer is 16. Yes, we are having our answer is correct. Okay, now how can we do it? So the following approach will make it easy for you to understand it. So what we can do, we can simply sort the array in the ascending order, because what we want, we have to change all the array elements equal. We have to make all the array element sets equal. So what we have to do to calculate the minimum changes, we first evaluate the median of the array. So why we are calculating the median of the array? Because the changes would be minimum to convert the smaller element to the median, and for the larger element, to make it equal to the median, we again require the minimum changes. Okay, so that's why we are sorting the array, and by sorting the array The middle element of the array would be the median. Okay, so this is the main motive of sorting the array. So first we'll sort the array in the ascending order. We have to evaluate the median and change every element to the median, because in that condition we get the minimum changes. Okay, so our array is 1296 of size 9, of size 4. So the median is 9 here. Median is 9. So for every element we calculate the changes. How we can calculate the changes? We subtract the particular array element from the median value and add it to our changes. So we are just calculating the absolute value for the array element and the median. So what we are doing, we'll traverse the array and calculate the changes. So first of all, what we are doing, we are sorting the array. We are calculating the median. For every element, we are finding the absolute value, that is the changes required to convert the particular value to the median. We are calculating that, and after that, when this loop is over, we will return it. So this approach requires a time complexity to sort the array, that is n log n, and to traverse over the array we require n time complexity. So overall time complexity, if we neglect this, because it is not the determining time complexity, so we can say the time complexity is n log n and the space complexity of is order of 1. Okay, so can we do something better? Yes, we definitely can. Okay, so we just want, because it is a redundant step, because to calculate the median we just are increasing the time complexity of the question. So if there is a method to calculate a median, it would be easy for us. Okay, because why we are sorting? The purpose behind the sorting is to calculate the median simply. And if there is a method that without sorting we can get the median, so we can easily solve it in lesser time complexity if there's a method to calculate the median in the lesser time complexity. So in C++, we have a method named nth element that is available in the standard library. So nth element, what the nth element will do, it receives three parameters, that is the begin iterator, the position to be fixed, and the end iterator. I will explain you this function. So the nth element, let us fix the particular element in the array that will be internally sorted, but it requires just the time complexity of order of n. So what I am trying to say here, so we have this array, this unsorted array. Let's suppose I take one of the test case. uh, I take one of the test case. Let's suppose 2, 5, 3 and 10. We have this array as a test case. So what the nth element function will do, it will receive the begin iterator for the array, and it will internally make this array as sorted. Okay, internally make this array as sorted. We don't have to make the whole array as sorted. It internally represent the array in the sorted form and fixed the particular position for the element in the array. Okay, for particular element we can fix its position in the array. So if this array would be sorted, it would be something like 2, 3, 5 and 10. Okay, and we have to fix the median. So median is will be available at the size divided by 2th position. Okay, so we can fix it using the nth element function. We can fix the particular position in the sorted form of this array, and we can do it in order of n time complexity. Okay, so how can we do it? Let's suppose our array name is a here. Okay, we just use the nth element nth underscore element function, we'll pass the begin iterator. Then what we'll do, we have to fix the median. So to fix the median, if n is the size of the array, to fix the median, we fix the n by 2th position, and the third argument will be the end iterator. Okay, so that's how for this array, here, that what will be the arrangement of the array. Here we will get the median. We does not matter with the other elements, we just get the median at the n by 2th position. Okay, so here can be 3. So the array is not sorted, but we have fixed the median at the n by 2th position. Now what will we do? If we know the median, we can easily calculate the changes. So we'll store this median in a particular variable, and the same procedure we will follow. Okay, so when we fix the median of the array, that will be present at the middle of the array. So this is how we'll do it. Okay, then we'll calculate the median because it is fixed. We'll store it in a particular variable, we'll iterate over the array and calculate the changes. At the end we'll return the changes, and it is all done because we have avoided sorting, because the only motive of sorting is to calculate the median, and we have calculated the median in order of n time complexity. So this approach requires a time complexity of order of n, and we does not require any space complexity, so space complexity will remain as constant. Okay, so these two are the approaches to solve the problem. So this is more for the C++ users, and this is a nice solution for this problem. So I've explained you the both solution for the problem. If you have any doubt, please feel free to ask. I will give the code link in the description, and I will meet you in the next video. Okay, bye.